My dear students, now we are going to look at the Mod-31 asynchronous up counter. We know in general how exactly the counter will be, up counter and down counter we have seen so far. So in up counter and down counter, what we try to do is any n bits, for example, it may be 3-bit or 4-bit, whatever it will be the number of bits. The idea is very simple, that we are giving clock to one flip-flop, rest of the clocks are generated from the previous flip-flops, and then we are trying to what exactly known as up or down based on whatever we require. Based on that, we are taking either output from say QA or QA bar, QB or QB bar, or QC or QC bar, QD or QD bar. Now in general, for example, if it is say mod 8 counter, mod 16 counter, mod 32 counter. Okay, number of bits are 3 flip-flops required, number of bits are 4 flip-flops required, number of bits are 5 flip-flops required. 3 flip-flops, 4 flip-flops, 5 flip-flops. We are not going to stop the count in between. Only thing is based on up or down, accordingly we do it. So in such flip-flops, what exactly we are trying to do is we are connecting all clears to 1, all presets to 1, active low presets to 1. That means neither we are presetting nor we are clearing. Okay, so none of the job is being done. So what we are trying to do is we are going to give the clock. This is our clock. Then what I try to do is there is a TA, TB, TC, both of them, all of the three will be 1. It is in toggle mode. Output of 1 is given to the next input clock. Output of this flip flop is given to the clock input of the next. Let's say this is flip flop A, this is flip flop B, this is flip flop C. Okay, so this is going to give you, if you take the output from say QA, here is QA, here is QB, here is QC, QC, QB, QA. So what exactly that we are going to get is, okay, 3-bit up counter, asynchronous of course. If you want a down counter, okay, what we need to do is same circuit. In place of QA, I will be using QA bar. So from QA bar, I am taking output. QB bar, I am taking output. QC bar, I am taking output. This is QC bar. This is QB bar. This is QA bar. Okay. So instead of QA being connected to the clock, this is going to be connected into the clock. Okay. So this we are exactly connecting. Okay. So if I do that, then I will going to get a 3-bit down counter. Okay. This is what we have seen already. Now what I want to do is, there may be up counter or down counter. If at all I want to stop in between at some point, if you want to stop. So what is that some point is, let's say if it is a mod 31 counter, that means mod 32 we know. What is mod 32? Mod 32 will go from 5 zeros to 5 ones. 1, 1, 1, 1, 1. No in between stoppage. Now if you want to stop mod 30 at 31, upon seeing 31, it is going, what exactly it should happen? What exactly should happen is it has to get reset. So what we can do is we can do like this. Whenever it come across 31, what is 31 equivalent code with respect to flip-flops? QE, QD, QC, QB, QA flip-flop inputs. This is LSB 0 0 0 0 0. So what is the last? It will come to 1 1 1 1 0. What is this value? What is this value? This is not 31. If you want 31, I should have this also. So this is 31. So let's take 31. So now what exactly that I am trying to do is, I am looking for a unique bit pattern which is not supposed to be there. That means whenever it come across this, it should get cleared. Clear should become 0. So what we try to do is, when these 5 inputs are 1, output should be 0. So what is such gate which is capable of doing that is, if I take the 5 input NAND gate, so one of the input is QA, QB, QC, QD and QE. So this output will become 0 when all are ones. When all are ones, then only it will become 0. So this we are going to collect it to the clear. So I will show you now the circuit diagram. It's very simple. What this is, there should be 5 flip-flops because it is Mod-31. Number of flip-flops required is 5. And what we try to do is, we try to clear it when the count reaches 31. How do we detect it? By using an AND gate. Okay. So all the clears are connected. Clear, 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 clear. All clears are connected to an AND gate like this. Inputs are 5 inputs. So the 5 inputs are QA, QB, QC, QD, and QG. And all are ones, output will be 0. And that is the case. Okay. What exactly that is going to happen? It will count from 0 to 30 only. It is not going to count up to 31. Then it will become mod 31 count. Okay. All presets are connected. We are not going to disturb any preset. All presets are tied together, connected to 1. Okay. Once this is being done, then what next that we look is, there is all flip-flop T input should be connected to 1. All flip-flops T input should be connected to 1. This is T input, T input, T input, T input, T. So there is a active low common clock. Okay, this is up counter. So QA connected to clock, QB connected to clock, QC connected to clock. Next flip-flop. Similarly, this is connected to clock. Okay. So now in general counter, where it is mod 8 or mod 16 or mod 32, we are not going to stop the sequence in between. We are not going to reset in between. Okay. So for rest of the flip-flops, for any mod count value, okay. So what we try to do is we reset wherever we want. So where we are resetting here, this we are A, B, C, D, E. Okay, this we are resetting them when it reaches 31. 31 we never see, all ones we never see. So we will see 0, we will see 30. Okay, after 31, okay, it will become 0. So it will change its abruptly. 31 to 0. We never come across 31. Okay. So this is how one can design Mod 31 asynchronous counter. Okay, it's clear.